Let's now look at the final 5-axis continuous strategy that we have available to us in Jewelry Cam, and that is swarfing. Swarfing is a strange term for cutting with the side of your bit. At some point, the developers of cam products utilizing 5 or more axes realized that now that we're able to tilt our model any which way we want pretty much, we are no longer limited to just using the tool tip, the end of the tool tip. We can also now use the side of it to make cuts along flat vertical walls. And Jewelry Cam extended this to be something of an art form. You could cut all sorts of things with swarfs so long as the walls are straight and don't have any features on them. For example, this model again that you saw in the drive surfaces video has these clean flat walls on the inside that would be nearly impossible to mill out with the reach of just a tooltip bit, and it would definitely take a lot of time. But using the side of our bit, we could reach much further and cut much quicker, and at the same time do it all cleaner. And the really cool part is that we can actually do it in fluid motions, just like we did with drive surfaces, rather than a series of independent toolpaths. So, for example, let's say we want to cut out this side, this inner wall. To do that, we need to create single curves that indicate both the lower and the upper boundaries of the cut. In this case, I will use duplicate edge command and select the edge that I require. And I will join them into a single curve. So there's one curve, and I will make it red color so it's visible. There's one curve, and the top side of my curve here is this. So I'm going to use the duplicate edge command here again, join, and once again, for visibility, I'll make this curve red. These curves will be useful to us to tell Jewelry Cam where the boundaries of our swarfing areas are, and as well as which direction to approach it from. So we click on New Custom Operations, select Swarfing. Well, first we're asked to select a swarfing surface. It does have to be a single surface. It cannot be a poly surface. If it is, then you'll have to cut into two separate toolpaths. In this case, this is a single unified poly surface, or rather surface. So we can select in one go and press enter. Now we're asked to select our lower lead curves, which is this part. And this is the reason for creating this curve before engaging in the selection of this strategy. If we just took the edges, they would be seen as separate curves, unconnected, and Jewelry Cam would basically cut out, say, this portion, but then stop. We need to have a continuous line, and that's why we extracted these edges and joined them together. Once we selected our lower lead curves, we press enter, and we select our upper lead curves, we press enter, and we're given a few options. Let me just set these to default and press calculate. And here's our result. We could see that our toolpath goes down, around, and comes out here. Let's look at in the simulator. There's our cut, round, and out. in one movement. We've been able to curve out that wall. So, a few options to keep in mind. We can specify number of layers, which is actually quite useful to do. I like using at least a couple, probably 3 layers, which will automatically offset the initial cut several distances away, however distances you specify here. So 3 times 0.1, about 0.3 of a millimeter here, and 0.2, and then flush against here. And the reason being is that if it's the very first cut you make in this solid block of wax, you have a chance of pulling it a little bit as you drag the tool bit across. So you're better off making this cut here, so if there's any deviations or pulling, it happens at a distance away. And then the next couple of succeeding cuts are now working on a very, very thin layer that they must remove, and they can do so very cleanly. If you wish, you can make this operation even more reliable, if you will, by first creating a duplicate operation with a clearance. So, for example, a clearance of 0.5 millimeters. What this will do is, in addition to that offset that you specified, it will also offset to begin with, or kind of as an ending result. So, at best, you're going to have a skin of 0.5 millimeters away from your final operation, and then you could create another operation that does the finishing job. So you can think of this as your rough swarf and then a final swarf. Just remember to set it back to your actual proper zero clearance for the final operations. And that, in a sense, is it for swarves. I just want to demonstrate what would happen if you didn't create those curves to begin with and just use the edge definitions. So you still select your swarfing surface, and now you select your edges directly on the model, ignoring our existing curve. And you're certainly allowed to select all of these, but it's just that the result that you will get is not what you expect. So here we are. We did the same thing. We calculated, and our result is some sort of a mess. Occasionally, you can get a part of the surface swarf this way, or you could even break it up into smaller segments. For example, you say, I'm going to still deal with this surface, but now only this edge. Actually, it's probably not the best example. Let me pick something that's kind of that has an upper and lower boundary. So let's say this segment, enter, and this segment, enter. So now you get, well, this is just a plunge, so that's why it's no longer following this wall, but it is at least avoiding the geometry. And you do get these nice swerves just carving out this section, but then stopping. And that's exactly why it's worth your while to take the time to create connected single curves before doing the swerve strategy, and then you're able to make these nice cuts all in one go. And that completes your variety of strategies in jewelry cam. And all that's left to do now is to look at some auxiliary functions which are quite useful that exist in the jewelry cam toolbar. And that'll be reserved for the last lesson.